Greetings, I'm Yvonne Stapp for Science for the Public, and I welcome you to Contemporary Science, Issues and Innovations. Many prominent astronomers have offered their views about the possibility of intelligent life elsewhere in the universe. One of them is Mario Livio, who was a distinguished astrophysicist at the Hubble Space Telescope for more than 2 decades and is still a prominent, active writer and speaker. Recently, Dr. Livio wrote a very interesting article in Scientific American about whether we Earthlings hold a privileged place in the universe or not. And today, he explains how scientific discoveries and theories over time have shaped that speculation and what the current views are. Dr. Livio, thank you so much for joining us today.
My pleasure.
And I will start off by asking about this very interesting article and we'll put the title on the screen for viewers, that this is about something called the Copernican Principle and has to do with whether humans should think of themselves as unique in the universe or not. And he seemed to be well ahead of the time in his day and said at the time that we probably were not. But could you explain to us what that issue was, what he was trying to say?
Yeah, well, it all started with Copernicus, and this is why it's called the Copernican Principle. Copernicus was the person who, changed our view of our place in the cosmos by saying that not all the planets and the sun revolve around us, but rather we and the other planets revolve around the sun. So basically, he demoted us from being central to what at the time was considered the universe to something rather more ordinary, like, a planet like other planets. Now, the reason this has been elevated to the status of being called a principle is that since the time of Copernicus, many other discoveries have shown us really how non-special we are in the universe. And there are many of those. So, just to mention a few.
Yeah.
So, for example, Charles Darwin showed us that rather than being, the so-called crown of creation, we are really just a normal product of evolution by means of natural selection. Harlow Shapley, an astronomer, showed us at the beginning of the 20th century that the solar system is not at the center of our Milky Way galaxy. Mm-hmm. It's actually kind of in the suburbs of the galaxy. Edwin Hubble, after whom the Hubble Space Telescope is named, showed that there are other galaxies other than our Milky Way galaxy. And in fact, today, some estimates put the total number of galaxies in the observable universe at some 2 trillion such galaxies. We've even discovered that there are in our own Milky Way that roughly one of every 5 stars, like the sun, has a planet a little bit like the Earth, orbiting it in what we call the habitable zone, which is that sort of Goldilocks zone, which is neither too hot nor too cold, so that it allows for liquid water to persist on the surface, so that in principle it can harbor life. So all of these discoveries have basically shown that, with every step, our physical existence is really nothing special in the universe.
Right, and so this is interesting that this took place, the shift took place in a relatively short period of time, really, but the it showed that we were not so special. That was the indication, apparently. However, now that people like you have done all of this inspection of the universe as far as we can, have things changed, ideas changed. So everybody's out there looking for life elsewhere. What's the current position?
So concerning life elsewhere, we have finally reached a stage where astronomers, planetary scientists, and so on can actually really attempt to search for life elsewhere. And I don't mean necessarily intelligent or technological life. First of all, even simple life, maybe bacterial life. And this actually is taking place. It's a three-pronged attack on this problem. Namely, there are people who are looking for life on planets or moons in our own solar system. For example, on Mars, on Venus, and on some of the moons of Jupiter and Saturn and so on. So this is one serious effort. There is a second effort taken by astronomers to look for signatures of life, we call them biosignatures, in the atmospheres of other planets revolving around other stars. And then there are some people who try to take a shortcut through all of that and search for some technosignatures, some radio signals or something from something that could actually show an intelligent technological civilization. So all of this is taking place right now, but I should say that to date, we still don't have any unambiguous sign of life anywhere other than Earth.
Okay, so that's one problem, and despite the fact that there's a lot of noise, it seems, about UFOs and visitors joining us here and there, but we haven't really identified anything just yet. Now, right now, another sort of theory is very popular that you discuss in this article, and that's the multiverse. And how has that changed, if it has, this idea of whether we're special or not?
Yes, so this is actually a very interesting thing, and it's something that I would say maybe a few tens of years ago we didn't expect to go this it sort of was kind of thrust upon us as scientists. For many years, we wanted to think that, we can explain everything, find theories that will explain everything in our universe. But we discovered that maybe that's not quite the case. And in the same way that we discovered planets around other stars, some scientists, myself included, have started thinking about the possibility that maybe even our entire universe is not all there is, but it's just one member of a vast ensemble of universes, and we call that the multiverse. Now, this is a very speculative idea. I should emphasize that, and we currently don't really have any strong evidence to, prove that such a multiverse exists. But the existence of this multiverse actually affects the Copernican principle in two opposite ways, interestingly enough. In one way, it says that we are nothing special. Even our entire universe is only one member of a huge ensemble of universes. So that strengthens the Copernican principle. On the other hand, these same researchers who suggest this say that the laws of physics and the values of what we call constants of nature, things like what is the strength of gravity and things like that, may be arbitrary variables and have different values in these different members. And if you already allow for such a thing, then clearly many or most of these universes will not even allow life to appear there. Because, for example, those universes will be expanding so fast that galaxies will never form. Or, you will never have the chemistry of the type that you have in our universe, and so on. So that means that only a relatively small subset of this multiverse will actually be, contain universes that allow for complexity and life to emerge. Now, of course, we find ourselves in one such universe. Now, that subset is now a little bit special. So this is where the multiverse suddenly implies that maybe we are somewhat special after all, because we are only in that so small subset that allows complexity and life to emerge.
Yes, I see. This gets more and more and more speculative, but then from the very beginning, things start out as speculative and then can be maybe proven later. But Dr. Livio, I have to ask, in terms of just our universe, there are two things. I wonder if you'd explain the constants, and then I'd like to ask about the nature of life. We have like one idea about life, what comprises life, the elements that would form life. And so there's a question about whether that is necessarily the case throughout our universe. The other thing is the constants of this universe. You just mentioned them briefly there. Could you just give us a little background about that?
Yes. So our universe is characterized by a series of some 30 or thereabouts numbers, which are constants. For example, the strength of gravity, the strength of the strong nuclear force, the ratio of the masses of, let's say, a proton to an electron, things like that. So the ratio of masses of subatomic particles, things like the ratio of dark matter to ordinary matter in our universe. These constants in our universe have been such that clearly they have allowed life to emerge and to evolve. We are the example of that, yes? Now, it could be, if it turns out that if you actually change the values of these constants, then life may not emerge and evolve. For example, if the electromagnetic repulsion between particles was much stronger than it is in our universe, then maybe you couldn't form any atoms heavier than hydrogen, in which case you clearly couldn't do the chemistry and life to emerge. So clearly our universe had to have values of constants that are consistent with our presence here. Now, you also asked about, is there only one form of life that can appear and so on, which is a somewhat different question. This is within our universe, within our universe itself. Well, again, because we have not found yet any other life, it's hard for us to tell. But people who have tried to look at other possibilities of life, for example, life on Earth is carbon-based.
Yes.
Carbon is, the thing the atom that. Now, people have looked at, could you use other atoms, like silicon, which is relatively similar to carbon? Well, it turns out to be really difficult because carbon really has the capacity to form very complex links to other and bonds with other atoms and so on. And it appears very, very hard to form the diverse chemistry that was responsible for the emergence of life. And it's not just that, could you have solvents other than water, for example? Maybe things like liquid methane and so on. Liquid methane exists on, Titan, which is a moon of Saturn, for example. Well, the temperature there is very, very low. And so it's hard to see how chemical reactions could work because they would be extremely slow. So I'm not saying it's totally impossible, but it is definitely harder. So we have not given up on trying to explore whether other possibilities for life exist. But we, at the moment, life as we know it on Earth appears to be a very good path, and maybe that's how it happened.
Okay.
There is, however, one thing I should mention.
Mm-hmm.
I'm talking about life emerging spontaneously out of chemistry.
Mm-hmm.
This is the carbon-based life we're talking about. Now, as you know, artificial intelligence has evolved enormously already and will continue to evolve very fast, extremely fast. So, in principle, there could be life forms that are based on artificial intelligence. Those have not emerged spontaneously from chemistry. They were done by some previous intelligent civilization like us. Yes? Now, those are not carbon-based.
True.
So you could have other forms of life that are not carbon-based, but which did not emerge from simple chemistry.
Yes, I want to come back to that in just a minute because that sort of overlaps another article that you wrote with Martin Rees that I wanted to ask you about that AI issue. But you'd still start with life somewhere. Artificial intelligence wouldn't just emerge by itself. But one thing I want to check with you, since we haven't found intelligent life yet, which doesn't mean we won't find it tomorrow or something, but the elements for life are almost ubiquitous, it seems, in the universe. They're very common, but you need to have an environment that promotes the development of life, apparently, if that is necessary to have those particular things: carbon, oxygen, hydrogen, nitrogen, and so on, the 6 basics there. Do you have anything to say about that these are very widespread in the universe, and yet we haven't come up with discovery of life? Is it just too early?
Yeah, it is too early, and the reason is the following. You see, we can make simple calculations and say, okay, look, in our own galaxy, the Milky Way, we may have a few 100 million, or maybe even as many as 1 billion habitable planets, in principle. And in the entire universe, as I said, we may have 2 trillion such galaxies. So, okay, you multiply 1 billion by 2 trillion and you get a very large number. And then people tell me, so how is it possible that we will not have life in all these other places? Yes, I like that as a sentence, in the sense that I like the idea that we are nothing special. But we really cannot tell, even with those huge numbers, that means that life has emerged elsewhere. Why? Because we don't know yet what is the probability for life to emerge, even if you have all the right chemistry and the right environment and everything. And maybe that probability is even smaller than 1 in 1 trillion times 1 billion, and so on.
Right.
So as long as we have not found any other, confirmed life elsewhere, we really cannot tell, even with those huge numbers.
Yes.
Now, the good news is that as soon as we find one other example, then probably we can say that there are lots of them. Because, there is this kind of principle of 0, 1, infinity, which says either something is completely prohibited, or there is one example, or there are, an infinite number of examples. As long as, if we find another one, it will mean that there are probably many.
Yes. I want to go to that artificial intelligence sort of development in just a second, but before that, one more point that you made in this particular article was the possibility of the prematurity of life on this planet, that we occurred sooner than you should expect it to evolve in the universe. Could you give us a little background there?
Yes, yes. So, look, I mean, if you look at our own universe, yes, most stars are low mass stars, stars that are smaller than the sun. You get more and more stars the smaller you get. Also, those small stars live much longer. Our sun, the lifetime of our sun is about 10 billion years. A star that is only 1/10 the mass of our sun can live trillions of years. So most stars in our galaxy are of low mass and they live for very long. And that means that if you calculate, based on what we know, what kind of is the probability of life emerging somewhere in the universe, you find that naively you would expect that life will emerge actually a long time from now on a planet revolving around a very low mass star. That is the thing. In which case, we are kind of premature. Because we live around not so low mass star, and we have appeared already. So that could be surprising, or it could make us special in some way, that we appeared too early in the life of unless there is somehow something that prevents life from appearing on planets around such low mass stars. And actually there are things that could prevent that. For example, these low mass stars tend to have strong flares where they, emit a lot of radiation and particles, and those flares and things could strip their planets of their atmosphere, for example, and so on. If that is the case, then, maybe life cannot emerge on those stars, and then it brings us back to being mediocre. We're not premature. If on the other there isn't, then we are premature. So again, our current searchers for life, which actually concentrate on such low mass stars, planets around such low mass stars, could actually tell us whether we are in this sense special or brings us back to mediocrity if we cannot find any life around such stars.
Yeah, right. Thank you for that. And in our remaining minutes here, I wanted to get back to that kind of evolution into artificial intelligence life, which is very interesting. So you alluded to that in this article a little bit, and then in another article recently with Martin Rees. And that is that the life that we might find might represent artificial intelligence life, which makes a lot of sense for anything flying around in the universe, not on a planet. Could you explain that, how that might evolve, and we might too?
Yes. You see, first of all, our own capacity in terms of mind power is limited because our brain is limited, and how much more it can develop is limited. Maybe we are reaching kind of the limits of our evolution. On the other hand, the intelligence of machines is only growing all the time, and in fact it's growing very, very fast, as you know, as we have seen even in recent years with the development of artificial intelligence. Now, the artificial intelligence that we have today is still not comparable to that of humans in many respects. I mean, yes, these machines can do some things that humans cannot do, But for example, most important, they don't have what we might call consciousness. Now, whether these machines will ever have consciousness or not, it is not known. It depends on whom you ask, basically. But, some computer scientists and futurists think that these machines will eventually become conscious, and that this will happen, well, if not within tens of years, then maybe within 100 years, or maybe even within a few thousand years, but which is also nothing compared to the age and evolution, of civilizations. So if that is true, which we don't know at this point, that means that there will develop some sort of an intelligence which will be able to live for very long, much longer than biological life, and in which case, the universe may be filled with that type of intelligent civilizations rather than the biological. The biological may be just a relatively short phase in the evolution of civilizations. And that means that the way we look for other civilizations will have to change, because we have to look not for biological life on the surface of small planets and I don't know what, but something completely perhaps different, because most of intelligent life is artificial intelligence.
Yes, that makes an awful lot of sense if you think in terms of how we're looking at for UFOs and things like that, life in the universe. We think of it moving around in the universe a great deal, and it makes more sense that anything flying on a UFO would be artificial intelligence. It's very hard to imagine life like our own surviving for many, many years on a starship or something like that.
Correct. And
what's
the other
your
hand,
view?
I don't want to encourage too much the UFO literature and so on.
Right.
I mean, we are yet, I think, to find, something that is unambiguously, some form of life, technological life from elsewhere. I'm not saying that they cannot be.
Right.
I'm saying that, we should be careful with, before we state with any kind of certainty that these things exist.
Right. But in your mind, and it's a very interesting perspective, that this artificial intelligence phase may supersede the biological phase.
Absolutely, yes.
That's what you're thinking for the future, for us as well as life elsewhere.
Yes,
that's
correct.
it. And that's worth another one of your great books. You know that. So I hope you will look into that. I would like to mention that you did this other very interesting article on this subject with Martin Rees, another famous astrophysicist, but we're low on time now. And is there anything else that you would like to add quickly to this before we leave?
Well, no, the only thing, I would say is that, this Copernican principle, teaches us humility. Yes, we're nothing special and so on. But at the same time, every step that I mentioned, every discovery that made our physical existence less special actually made our knowledge more special.
That's right. Yes.
So in some sense, our mind expanded just as fast as this diminishing of our physical existence.
Oh, a very good point. That's really...
And that's a very important thing to remember.
Yes, and this has been wonderful to talk with you about this. Do write another book on this. And Dr. Livio, thank you ever so much for joining us today.
My pleasure. My pleasure.